All right, so let's look at question number 2 now. So let me help you. So whenever you see a question, first of all, to even attempt to solve the question, you must understand what the question is saying. Try to figure out what the questions has given you. That's the facts or the resources that the question is giving you. Try to understand what the question is asking you to do. Then when you know these two, what you have to do is to figure out what to use, the resources to use, given from the resources given from the question. You have to use the resources given from the question to solve what the question is asking you to do, or to find what the question is asking you to do. I hope that's fine. So in here we know that the question is saying ABCD is a square. So fact 1, ABC is a square. Fact 2, P and Q are midpoints of BC and CD. So you realize that first of all you must know what a square is. If you don't know what a square is, in fact you can't do anything about the question. So you know what a square is. So that's your first fact, or that's the first resource the question has given you. P and Q are midpoint. That's another key resource the question has given you. So you have to know what a midpoint is. If you don't know what a midpoint is, you are lost, right? So you need to know what a midpoint is. So P and Q are midpoints of what? BC and CD respectively. And they've given you that what? The vector AP is equal to the position vector A, and the vector AQ is equal to position vector B. Position vector is explain that later. Okay, now they're saying that find in terms of A and B the directed line segments in the same way. What it means that we are finding the vectors AB, vectors AD, vectors BD, and vectors CD in terms of what? Position vector A and B. That's what the question is asking you to do. So the question is giving you 3 points or 3 resources, a square, midpoints, and this conditional statement, right? That's AP is equal to A and AQ is equal to B. So you're supposed to use these 3 keys to find the vectors AB, AD, BD, and AC, right? Okay, so let's get to it. All right, so before I even attempt to solve the question, let me explain what a midpoint is, because I'm sure as of now you might not know what a midpoint is. So suppose that we have a line segment, right? So this is our line AB, right? So A is a point, this point, B is a point, this point, and it form a line segment AB. Sorry. All right. Okay. So we have this nice line AB, and we are suppose that we have another point here which divides the line AB equally, right? So we call this point C. So C divides the line AB equally. So if C divides AB equally, it means C now becomes what? The midpoint. Midpoint means the point in the middle of the line. Midpoint. So C now becomes what? The midpoint of the line, what? AB. Right. Now, what does this mean in terms of math? This means that the magnitude AC is what? Is half of what? Of the magnitude AB. Meaning that the line AC, now you realize that now A and AC now forms what? A line, right? So now the line AC, its length is half of what? The length of what? AB. What is trying to tell you that the line AB is twice the line what? AC. That's what it's telling you. So the point of a midpoint, or the understanding of the midpoint, gives you the mathematical understanding that we have that this AC now was what? Is half what? AB. Or you can say the line AB is now what? 2 of what? The line of AC. So it means that the length of the line AB is now twice what? The length of the line AC. You understand? So given that C is a midpoint, we've deduced these two things. Now I hope you understand what the importance of the midpoint is. Okay, so now supposing that you now understand, or you have a basic idea of what a midpoint now is. Now we move to our question. So suppose this is our nice square. It doesn't really look like a square, but we'll take like that. So this A, this B, this C, this D. Now you have to be careful when you are naming your square or your points, right? Now you see how I named it. I moved from A, B, C, D. I moved in a clockwise direction. I can't do A, B, then go and do C, D here. No, it won't help me. It will give me problems. So it's either you move in this order or in this order. So you move in this order means A, B, C, D, or A, B, C, D. You can actually start anyway. You can even start from here. A, B, C, D. Just that move in that same order. Don't try to jump to, yeah, okay. So now this is my vector AB, right? So if I give it this direction, this is now vector AB, this is vector BC, this is vector DC, this is vector AD, right? Okay. So this is the square that the question has asked. So this is my first resource down, my key resource. Then the second resource now says that P and Q are midpoints, right? So P is the midpoint of what? Of BC. So now in the case where BC, so this is the line BC. Okay, so this is the line BC. So if this is the line BC, then P must be a point here dividing BC, right? So this is my P. So this is P, it divides BC, right? Now what is Q? Q is also what? The point dividing what? CD. This is CD, yeah. So this is Q. It divides what? CD, right? Okay. So given that P divides CD, given that P divides BC, it means that what? The line BP, blood pressure, BP is equal to what? It's half of the line what? BC, right? You will probably use this somewhere, so you just put it down somewhere, and your line you can make it a line or even a vector. So the vector, no, so now BP now becomes what? A vector. So the vector BP is now what? Half of the vector BC, right? And the vector CQ, the vector CQ is now what? Half of what? The vector CD, right? Okay. So based on the fact that P and Q are midpoints, I have deduced these two nice equations that I'll probably use. Okay, all right. So now I've listed two of my key resources, square and P and Q be midpoints, right? Okay. The third thing that the question gave me is a conditional statement, which says that if AP, vector AP is now what? A, and my vector AQ is now B, right? So what is vector AP? Now you can draw your vector AP on your diagram so that you know what you're looking for. So this vector, this vector AP, right? AP is now A. This vector AQ, acquaintance. So AQ is what? B, right? Okay, so APA, AQ, B, right? So now these are my vectors AP and AQ. So now I have everything set. Now the question is, what is AB? So I can come here. So I'm looking for what? AB. But I'm looking for AB in terms of what? A and B. So AB. So what is vector AB? Now you realize that if you've watched the video, you know. Alright, so if you've watched the video, you realize that your vector AB, right, is the same as what? AP plus what? PQ. So it means if I want AB, I can move from what? AP to what? PQ, right? Or you can say that AP is what? AP is what? AB plus what? BP, based on what you are looking for. So me, I'm looking for what? AB. So since I'm looking for vector AB, and vector AB I know from this analysis, we call it the resulting vector, right? Or the triangular addition of vectors, something like that. I think forgotten the actual phrase for it. Okay, so AB I know it's supposed to be what? AP plus what? PB. Those who did in math, right, you remember that if you're adding two vectors, they said that they have a nice way of saying that, forgotten. The end part of the first vector should be equal to the beginning part of the second vector. What I'm trying to say that for you to add two vectors, this and this must be what equal, or they must be the same letters, right? So it means that AP plus PB will give you what AB. Okay, so that's my vector what. That's my vector what AB. Now I know that vector AP is what is A, right? So at least I'm in progress. I'm making progress, right? Now what is PB? Now PB is what? Remember, PB is what? Or we know. Okay, let me. Okay. Now what do we know from our midpoint scenario? We know that BP is what? Is half. Sorry, it's half. Forget about this thing. It's half BC, right? The paper is small, so I'm struggling. Okay, so BP is what? Is half BC. That we know from here, the analysis we made. Okay, now, but PB is not equal to what? It's not the same as BP. This is PB. PB is what? Is moving in this direction, right? PB is moving in the opposite direction. So it means PB and what? And BP are the same, but they're moving in opposite direction. So it means that what? My BP is negative PB, right? Or in other words, PB is negative what? Negative BP. Alright, since I want PB is what? Negative BP, right? So it means my PB is going to be what? Since BP is half BC, I'm just going to replace it, right? Substitute it. So my half is going to be there. Can bring my bracket. So half what? Oh, okay. Let me move to a fresh paper, right? So I have that PB is equal to what? Minus half vector BC, right? Okay, so right, we have now PB. Okay, so we now have that what? My AB is equal to what? AP plus minus half BC, right? Okay, so I have AP minus half BC. Okay, I know that my AP is A, right? But I still don't know what BC is. Do we know what BC is? No. So I have to come back to my diagram to come and find BC. Okay. So what is BC? BC cry is what? BC. Now, the aim is to write AB in terms of small a and small b. So I have to write my BC also in terms of what? Small a and small b, so that to make my work complete. Okay. So now I come to my diagram and I have to figure out how to write BC in terms of what? In terms of small a and small b. Now I make a very big discovery here. Looking at the square. Now one of the things that you must know is that whenever a question gives you like maybe ABC is a square, you must know the properties of the square, because the properties can help you. It can save your life literally, right? So based on the property of a square, I know that BC will be equal to what? AD, right? BC is AD. BC is AD. BC is AD. Now the reason I'm moving from BC to AD is because if I equate BC to AD, it's not like if I equate, they are equal based on the property of a square. A square is what? Based on the property of a square, opposite sides are normally equal. Not normally, they are equal. In fact, a square, all sides are equal. But then the parallel, they are AD and BC now becomes what? Parallel vectors. So since they are parallel vectors, it means that AD and BC are now what? Equal, right? Okay. So now we have the what? AB is actually A minus what? Half BC. Let's call this equation star. Now we also know that vector BC is equal to what? Vector AD, based on the properties of what? Maybe by properties of square, right? So BC is equal to what? AD. So substituting this into what? Equation star, I have that my AB is now what? A minus what? Half what? AD, right? Okay, so now the reason why I made this substitution is very important because I know I can find AD in terms of what? Small a and b easily, and find BC in terms of what? Small a and b. So you need to be sharp so you can observe some of these things. Now, some of these things, when you are new to it, it's difficult to observe them and spot them. But as you do more examples and you are exposed to different questions, now you will, as time goes on, you are able to spot some of these stuffs. Okay, so you don't worry if you're not able to spot it, it's fine. Okay, so now I come back to my graph or my diagram to come and find out what AD is. Now AD is what? AD is what? AQ plus what? QD. So I now come here, my AD, but AD is what? It's AQ plus what? QD, right? That should be easy. Now, what is AQ? AQ from the question is what? It's B. So based on that, you know that, hey, I'm making progress. So if AQ is B, so now it means my AB is now what? A minus half into brackets. Now AD is what? B plus what? QD. Right, so I now have that what? My A is now, my AB is now what? Half B minus what? Half QD. Now, still, I'm not done. I have to get rid of the QD, but I'm getting closer. At least I have now the A and B inside my solution, so I know that I'm getting closer. Now I have to get rid of this QD. Now what is QD? I go back to my graph. QD. I know that Q is what? It's a midpoint of DC or CD. So it means QD here, right? QD here, or if you have to be very careful with the direction. So if you're moving from here to here, it's CD. If you're moving from here to here, it's DC. If I'm moving from here to here, it's DQ. If I'm moving from here to here, it's QD. So you need to be very careful with the direction, right? So for instance, I know that DQ is half of DC, right? DQ is half of DC. Look at the direction. DQ is half of DC. So the vector DQ, so I know that the vector DQ is equal to half of the vector DC, right? Okay, so now but I have QD, I don't have what? QD. I have QD, but I don't have DQ. So I know that my QD is what? It's minus what? DQ. Just like the first one we did. They are just what? What's the name? Opposite direction. So it means my QD now becomes what? Minus half of what? Of vector DC. Right? Okay. Now, minus half of vector DC. Now, if I substitute QD inside this, I still have to get rid of DC. Right? I have to get rid of DC. But then I also know, now like I said, some of this stuff, as you saw more examples, that's where you get to expose. Now you know that vector DC and vector AB are what? They are equal. They are parallel vectors, right? So they are equal. So vector DC should be equal to vector AB based on the properties of what? Of a square. So it means DC is equal to what? Is equal to AB. So it means my QD now becomes what? Minus half of what? Of AB, right? So call this equation H. Then go and substitute this into what? This equation. That's the equation circle, right? So you're going to substitute equation H into what? Equation circle by substituting QD, right? So now I have my AB. AB is equal to what? A minus half B minus half QD. So A minus half B minus what? Half QD. And my QD is what? My QD is what? Minus half AB. QD is what? Minus half AB. So I just substitute. So my half now AB to be what? I have AB to be A minus half B minus half into brackets minus what? Half B. It's just substitution, right? So I now simplify. Now I'm almost done. I now simplify. So minus half times minus half gives me positive. So I'm going to get positive 1 over 4ab, then equal ab. So I now have ab. I just have to group like terms. The moment I group like terms, my work is done. So I'm going to have ab minus 1/4 ab equal what? A minus what? Half b, right? So if I solve this, I should get 4, 3. So 3 over 4 ab equal what? A minus what? Half b. If I multiply through by 4, I'll get 3ab equal 4a minus what? 2b. If I divide both sides by 3, I get ab vector ab now becomes what? 4 over 3a minus what? 2 over 3b, right? So it means from my analysis, I've solved what my vector ab is now 4/3 of a, small a minus or 2/3 of what? Of b. So I'm able to so based on that, I'm able to write vector ab also in terms of what? Small a, the position vector small a and what? And b, right? So you can use the same analysis to solve the other questions.